All right, hello Algebra 2 class. First I wanted to go over your warm-up from last class, the SAT question. Some of you guys said IDK as your response, so maybe let's check that one out. I don't know if you saw the email from school, but the SATs are not happening on April 14th as scheduled, and they might try and reschedule them for the fall, but no word on that yet. So you guys get a little break, but we're still going to do some practice. So when I look at this question here, it says A is a constant. Remember, a constant is just a number. That's all we're looking for. So it wants to know what is the number that A should be to make both sides of that equation equal. Well, in order to figure that out, we have to do some distributing, right? So I get 5x plus 5a, and then I'm going to distribute the 3 plus 3x squared minus 3a. Now combine like terms, and we're going to write it highest power to lowest power, so descending order. So 3x squared goes first, and then I have plus 5x, and then next I have 5a minus 3a, so plus 2a. All right, and right now we want that to be equivalent to 3x squared plus 5x plus 4, right? Well, if I'm trying to solve for what a is going to be, a only shows up here, and this piece 2a is supposed to be the same thing as 4 if both of these equations are equal, because the rest of the pieces are the same. So that means I'm just thinking, well, then 2a has to equal 4, so a has to equal 2. So don't be scared by the language about a being a constant. It's really just asking you simplify in the way that you know how with multiplication, and then make both sides equal. All right, so today we're going to move on to the second type of factoring. And if we were in class, I would have photocopied this little note sheet on some nice pretty paper, but you can either print it or sketch it in your notebook. I'll attach it in the remote day folder again. But first, we're going to talk about how to use this. So factoring polynomials, we're going to spend quite a bit of time working on this, and really what it's doing is helping us find the graph of a parabola. And these are all the different ways in this chart that we can factor polynomials. So it says in the very center, first look for a GCF. So that's what we've been working on, remember, so that's our greatest common factor. And just to refresh, let's do a little example up in this empty space up here. Let's say we had 5x squared plus 15x. Well, remember, I have to look at what's in common. What factor do they have in common? Well, with 5 and 15, it would be 5, and x squared and x, it would just be 1x. So that goes out front, and then left over, 5x squared divided by 5x is just x, and 15x divided by 5x would be 3. So that would be my answer there. But today, what we're going to look at is factoring a trinomial. So we talked about that word before, meaning that the polynomial has 3 terms. So again, when we're given a problem, eventually I'm just going to give you a problem and not tell you exactly how to factor it. So when we're given a problem and we're not told how to factor it, the first thing we look for is a greatest common factor. And once we've done the greatest common factor factoring, if we could, then we're going to look to see if we can factor it with one of these other ways that we see here. And today, like I said, we're going to focus on the trinomial. And it's a trinomial where there's no number in front of x squared, right? So we're just going to have the equation start, or the expression, sorry, start with x squared. This type of factoring is called product sum factoring. So you'll hear me refer to that quite a bit. So let's talk about a couple pieces of this. So with product sum, or with any quadratic really here, remember a is the value in front of x squared, b is the number in front of x, and c is the constant. And so that works for any quadratic function that we're talking about. And this type of factoring is only for quadratics, so powers of 2. And when we see that, we want to find, so this first one here, the product of the last number, or the product of C, and those two numbers have to also be the sum of B. All right, so in our case, and I usually make a little chart here, which I'm going to do off to the side, we want to find the product, and product means multiplication. So the product of C, which in our case is negative 42, whose sum adds up to B, which is negative 1. All right, so what we need to do, because this is a negative 1 right here, what we need to do is brainstorm what are the numbers that could multiply up to negative 42. And so I like to just make a little chart over here. So 1 and 21, 2, or sorry, not 1 and 21. I'm getting ahead of myself. 1 and 42, 2 and 21, 3 and 14. I don't believe 4 goes in, 5, 6, and 7. So those are all the combinations of things that multiply to 42, but we want negative 42. So we're going to have to assume that one of these numbers in the set has to be negative. So when I'm looking down the list, 1 and 42, let's say I made 1 the negative number. Well, then when I multiply them, I get negative 42, but when I add them together, I get 41, which is not negative 1, right? So that doesn't work. But I could also say, well, what if the 42 were negative instead of the 1? Well, then when we add them together, we get negative 41. Again, not negative 1, not what we wanted. 2 and 21, well, if I make 2 negative, I get positive 19. Or if I made 21 negative, I get negative 19. 3 and 14, I'm going to get, let's say I make 3 negative, I'll get positive 11. If I make 14 negative, I get negative 11. Still, none of these are working. But I know 6 and 7, those two numbers they have a difference of 1. So that's what I want here. So if I do negative 6 plus 7, I get positive 1, which is not quite what I want. But if I make the 7 negative, I get negative 1, which is what I want. So 6 and negative 7, those are my magic numbers here. And then factoring is just as simple as making your two factors. Factors are anything connected with multiplication. Since we start with the x, we're going to begin with the x in the parentheses. And then we have a positive 6 and a negative 7. So in one of the factors, I need a positive 6, and one I need a negative 7. It doesn't matter which number goes first or which number goes second, because in this case here, we have, when we're doing multiplication anyway, it's commutative, so it can be rearranged in any order. And if you notice, this is just a FOIL problem or double distributing problem we did the other day. So we're taking it from a simplified polynomial and we want to break it into its two factors. And like I said, soon we'll be able to use these to help us graph a parabola. So I'm just going to fill in this example on the chart here. We'll do this one next time, okay? But if you want to watch a few more examples, I'll do a few more down below to help us get the idea, and then you can try working on your assignment 6, I believe. All right, so here is another example. X squared plus 8, oops, not b. If it was really a b, then we wouldn't be able to do it. It has to be the same variable. X squared plus 8x plus 7. There's no greatest common factor. That's normally what I look for. So then I'm going to go, because it's a trinomial, and there's no number in front of x squared, there's really a 1 there, we're going to do product sum. So I'm going back to my chart. I need two numbers that multiply, or the product of them is 7. And I'm going to shorthand instead of writing the word product. I'm going to use the symbol for multiplication. And I need those numbers to add up to 8. The sum is 8. So product in sum. Well, we're getting pretty lucky here because the only thing that multiplies to 7 is 1 and 7. And those happen to add up to positive 8. because my last value is a positive number, I can remember how both values positive or both values could be negative, because -1 times -7 is also 7, but this would give me a sum of -8 instead, which is not what I want. Oops. So I already found my two numbers that quickly, 1 and 7, so my factors are going to be x plus 1 and x plus 7, or x plus 7, x plus 1. Again, they're going to give you the exact same answer no matter what. All right, let's try another one together. N squared minus 11n plus 10. So again, it's a trinomial. There's no greatest common factor of all three terms, and a is 1. So I'm looking for what multiplies to 10 that adds to -11. Well, my possibilities are 1 and 10, or -1 and -10, 2 and 5, or -2 and -5. Right, so I'm really listing them all out this time. If you can do this portion in your head, don't feel like you have to make a chart every time. I'm just doing it for a better visual. Well, so 1 and 10 add to +11. -1, -10 add to -11, which is what we want. 2 and 5 add to 7. -2, -5 add to -7. So it looks like the combination we want is -1, -10. So here n this time, because it's n squared, so n minus 1, and n minus 10. That's what we want there. I'll do one more example if you still need an idea of how to do this. So again, this time we have a trinomial. The last value, the constant value, is -12. So I need two numbers that multiply to -12, whose sum is +4. So let's list out what the options could be. We could have 1 and 12. We could have, and I'm ignoring the negative for a second. We'll come back to that. Actually, I guess we could do it. So -1 and 12, 1 and -12. We could have 2 and -6, or -2 and 6, and 3, -4, or -3, +4. Those are all the things that multiply to 12. The only one that looks like it's going to add to +4 is -2, +6. That's the one that I want. So my factors are x minus 2, x plus 6. If you want to check your work on any of these, you can always do it by double distributing this back together. So once I have my two factors, I could do x times x, which is x squared, x times 6, 6x, -2 times x, -2x, and -2 times 6 is -12. And that would simplify to exactly what we started with. So that's a good way to check and make sure you did it correctly. There is also a possibility that some of these will still be prime. So if you make this entire list over here and none of these numbers, combinations of numbers, actually give you the correct sum, then you can go ahead and write prime, just like we did with our greatest common factor factoring. So go ahead and give assignment 6 a try.